So a little bit of background, and then we're going to actually start talking about this, and we'll take a look at examples and everything else as we go through this. So we've solved systems of equations by graphing. And the two big things that we got out of that. Number one, we know what it means to be an answer to a system of equations. That is perhaps one of the biggest things that I want us to already understand. In order to be a solution to a system of equations, you are finding an x and a y value that when you plug them into both equations, make them both true at the same time. Okay? That's something that we should know and should be using to double check our answers. Okay? Now, we've also been talking about how you can use graphing to solve systems of equations. All right? And here's the nice thing about graphing. Number one, it is very, very concrete. Literally, you are showing people what you need to do to be able to find your answer on your graph, and you're physically looking for the point of intersection. Okay? And here's the nice part about it. When you solve by graphing, you're finding both parts of your answer at the exact same time. Okay? When you find out where your two lines intersect, you're finding the x value, you're finding the y value, and voila, you've got it. Okay? Now, here are some limitations on solving by graphing. Okay? And we already talked about some of them yesterday, but I'll remind you about them again today. One of the limitations of solving by graphing is your equations might be very, very difficult to graph on your 10 by 10 graph paper. So when you think about the example we did yesterday, I think it was the football tickets, right? How many total football tickets were sold? Something like 638 of them. So for us to graph that on the coordinate plane, we need a y-axis that goes all the way up to 638. Okay? That's going to be a bit difficult to do. All right? So that's one of the limitations on graphing. And here's another limitation on graphing. Solving by graphing works when you know you're going to get two whole number answers. So when it crosses at the point 3 comma 2, great. That's awesome. But what if it crosses at the value of x is 1.6 and y is 3.2? Is that going to be as nice to see on your graph? No. And I'm going to tell you right now, we're not going to expect whole number answers. When we're solving systems of equations and we're finding the cost of an item, it very well could be $2.45. Or it could be $3.70. Okay, we shouldn't expect whole number answers. So solving by graphing is a great way to introduce systems of equations. I'll be honest, out of the three methods, it's probably the least used. Simply because there are so many limitations with it. So we're going to move on to our second of our three methods today. This is solving by substitution. And I'm going to be very, very upfront with you. If I were to ask students to rank in order their least favorite methods of solving by substitution, 90% of people are going to say this is their least favorite because it's the hardest. Okay? Sorry. We have to deal with that, and we're going to learn from it. Now, what I did this morning when I came in, I kind of have a process that I use to solve a system of equations. All right? And you don't have to use this method, but I thought that it would be advantageous for you because I'm going to talk a lot about this as we start solving systems of equations. So if you remember when we started solving equations, I gave you a 4-step process to solving equations. You might not remember it, but it was always the same 4 steps. Number 1, simplify. Number 2, get variables on one side. Number 3, undo addition and subtraction. Number 4, undo multiplication or division. Okay, you might not remember that because that was like back in October, but we use those 4 steps to solve every equation we ever came up with. Okay? These are the 4 steps that I'm going to use when I solve by substitution. Now, some of these steps are already going to be done for us within the process. So I might not have to do all 4 of these, but in some of them, I may have to do all 4. Okay? So, I also tried to, when it's especially the first 2 steps, because these are the new things for us, I tried to give you some suggestions and some things to look for. Okay? So in problem number one, or step number one, when we're solving a system of equations, the first thing you need to do is you need to solve one of the equations. Remember, there's always going to be two of them. You need to solve one of the two equations for one of the two variables in the equation. So when you look at these problems after starting today, you're going to actually have four choices. Do I want to solve for x in the first equation? Do I want to solve for y in the first equation? Do I want to solve for x in the second equation? Do I want to solve for y in the second equation? I've got four choices to use. Here's my suggestion. I always look for a variable that's got a coefficient of 1. When I say coefficient, what do I mean? What's that? Well, what do I mean with a coefficient of 1? What's the word coefficient mean? This is a word actually from last year. You need to be familiar with it because it's the one that we use in math instead of just saying the other blah, 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 blah. Miles? It's the number in front of the variable. Okay? You're going to hear the word coefficient used instead of me saying the number in front of the variable. We have a name for it. It's called coefficient. Okay? Now, once this is done, then step number 2, this is why we call it substitution. You're going to substitute what you came up with in step number 1 into your second equation. Okay, now here's the big deal that I want to get you here. When you have done step number 2, you should have one equation left with only one variable. If you do not have one equation with one variable, you've done something wrong. Okay? And I'll be honest, that's usually the biggest error that I see made. Like students come up with an equation and it still has two variables. That doesn't do me any good. Okay? I should have one equation with one variable. Step number 3, solve the equation you created in the second step. This goes back to Algebra 1 and pre-algebra. Okay? This could be a multi-step equation, whatever it is. You need to be able to solve this. Now, here's where it's going to be a little weird. When we solved by graphing, we found both parts at the same time. We found the x and the y value. When you solve by substitution, and later on solve by elimination, you're only going to find half of your answer. You're either going to figure out what x is, or you're going to figure out what y is. Okay? So step number 4 says after you found the first variable, you have to plug that in and find the second variable. You got to find the second half of that answer. That's why there's a fourth and final step from that. Okay? All right. So keep this handy right next to you, and we're going to start taking a look here at example number 1A. Solve the linear systems of equations using substitution. So, number 1, solve one of the equations for one variable. Question, do we need to do that or is that already done? It's already done. Okay? Which equation is solved for what variable? The first equation is solved for 1. All right? So step number 1 is already done. That's not always going to be the case, but it is here today. Step number 2. Okay? Substitute the expression. What do we mean by the expression? You're going to substitute this expression in for y to your second equation. Okay? So what we're going to do is we're going to get rid of the variable y and we're going to replace it with 2x minus 3. Okay? So this is going to get plugged in for y right here. And when I do that, I should end up with an equation that has only one variable. Okay? So when I do this substitution, this second equation, when I start to write it down, becomes x plus. Now, how many y's are in this second equation? 3 of them. I still need 3 of them here. And if you recall, when we started doing substitution problems way back over 18 months ago in pre-algebra, when we substituted a number in, what did I always tell you to get in the habit of doing? Use parentheses. You're going to need to use parentheses here when you substitute your 2x minus 3. Then we continue with the rest of the problem. This is equal to 5. So here's what I want everybody to notice. Really what we have right here is x plus 3y equals 5. That's all we have, isn't it? But we got rid of the y and we replaced it with 2x minus 3 because that's what the first equation told us y was equal to. Does that make sense? This is like the big leap. And for some of us, it's an easy leap. Yeah, this makes sense. And other people are like, nope, not going to say it, but this doesn't make any sense to me here. Now, we've done step 1. Well, step 1 was already done. We did step 2, so now it's an important time for us to stop and look. How many equations do we have here? 1. How many variables do we have here? 1. That's what should happen. You should have one equation that has one variable. If we didn't do that, then we didn't do something right. Okay? What's step number 3 in our process say? Solve. Go ahead. Solve for x. This is going to be a multi-step problem. But we need to solve this for x. Okay, this is why those parentheses are important, because when I go to solve this, my first step is going to tell me that I need to distribute. So I have x plus 6x minus 9 equals 5. Then we're going to go ahead and combine our like terms to make it 7x minus 9 equals 5. Then we want to solve our two-step equation. So we add 9 to both sides, so that 7x is equal to 14. And then divide each side by 7, and x is equal to 2. So I'm going to pause there. Questions on how we got to this one? Now, what did I tell you? We only found half of our answer, didn't we? We still have to find the other half. What do we still have to find? You still have to find y. So here's what you need to do. You need to go back to one of these two equations here. You already know what x is. You need to plug it in, and you need to then solve for y. So just a quick question. If I can choose either one of these two, which one would be easier? The first one. I would plug it in right here. So if we do that, this now is going to say y equals 2 times our x value, which is 2, minus 3. And here's why I like this, because now I just have to evaluate over here. 2 times 2 is 4, and 4 minus 3 is 1. That's the second half of my answer. And what should we always do, ladies and gentlemen, if those are my answers? Check them. So, 2 times 2 is 4. 4 minus 3 is 1. 2 plus 3 times 1, which is 3, and 2 plus 3 is 5. There's the solution to my system of equations. It is the x and the y value that make both equations true at the same time.